Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallesham Devasane, I am working as an educator on Unacademy where I am taking the classes for theory of computation, compiler design, C programming and also for discrete mathematics. Good morning everyone. Ankita, good morning. Mahendra, good morning. Vijayant, good morning. Good morning guys, everyone. Good morning. And we are almost in the end of the theory of computation, and after this we will have a good practice on identifying languages mainly. Okay, if we get a time we will also go for closure properties of all the languages. Now here in this tomorrow class we will be looking at how to identify regular CFLs as well as decidable undecidable languages. So this is going to be very important session. Minimum 2 to 3 marks every year will be asked from this topic. So weightage is more than that, but just I'm talking about minimum. Definitely you can see that 2 to 3 marks. Okay, until 16th, but till tomorrow, that is TOC, and after that we'll be starting compiler design the same timing. And also you have a good news that but if you are okay with that, morning to today midnight 12 a.m. to 6 a.m. We are going to practice the compiler design, new questions, gate questions and complete practice like a C programming. But I want to take long session, but it is, if you are not able to attend the live, at least you watch recorded session, so which will help you to practice lot. Amjad, good morning. This is today night 12 a.m. and the operating system is started already, that is 11:30 a.m. and data structure is also started. That's running from 2:30 to 4:30. Later on all the subjects will be completed one after the other. You will be informed once the subject is over. Dates are already disclosed to everyone. In case if you are not following Unacademy, just visit my profile, click on follow, and you can find a lot of free classes. In case you need any referral code, you can use my referral code DEVALIVE to unlock the free plan. And also if you are taking the subscription, you can get 10% discount on plus or iconic subscription. If you want to know what are the classes that I have taken on Unacademy which are free classes, like so many quizzes I have conducted separately, all in one sessions where to give more insight into different topics, and special topics are mostly sometimes subject also completed like TOC, CD, and daily practice problems and PYQ series for many subjects. And this is my profile, unacademy.com/DevaGateCSE. And in case if you are not using Unacademy Learning app, go to Play Store and install Unacademy Learning app to watch the classes using mobile. And if you want to know about plus and iconic subscriptions, where live classes are always very important, so these live classes are very interactive on an Unacademy platform, and all the subjects are well structured, and structured courses you are going to get inside the plus, and you can attend every educator class. Even though you use my referral code, it's accessible to every course on Unacademy which is inside the plus. And here you will have weekly test, doubt solving sessions, and the language, the batches will be there for both separately English and Hindi. And iconic, you will have more advantage than plus, like you will have a personal coach, study material and study planner. And you know that I think from 18th Jan RBR is going to start the separate batch, that is eval batch for the GATE people. So in case if you want to take the subscription, please take the subscription as soon as possible. You may use my referral code DEVALIVE to get an access to every course on Unacademy. In case if you want to know the plans, plus you have various plans. Minimum 1 year is beneficiable, so you can go for either 1 year or 2 years or 1.5 year. You can see the price here: 27,225, 34,650, 39,600. Use referral code DEVALIVE. Similarly, Iconic, you have many plans inside again. So 24 months if you are going to subscribe, then 66,600. Yeah, that's all about the plans. Yes, Naskar, good morning. Lavjit, good morning. Nikhil, good morning. Good morning, guys. Okay, I hope you got an insight into regular languages, context-free languages, and a Turing machine, right? So when you are talking about these three languages, regular languages can be understood. If I want to build a Turing machine for all these three languages, I can design a Turing machine for regular language without using any memory. So I can just scan an input, I can understand the input. Now context-free languages, if I want to design a Turing machine, yes, I need to move forward and backward direction, but equivalently I can use one stack to understand the context-free languages. So regular languages can be solved without memory. Context-free languages requires memory other than the stacks we are talking about, other than the states. States are required for all of them. But regular languages, we don't need any additional support of the memory. Context-free language, we need a stack, unbounded stack. Turing machine, the tape, we are moving bidirectional. So now you can have 100 stacks, 1000 stacks, or 2 stacks, all your choices. Yes, now you can have any kind of memory capability. या लवजित, आज मतलब 12 बजे, आफ्टरनून नहीं, रात को 12 AM to 6 AM. yes. Raj, it's not avoid. Normally those people who are not able to sleep, some people definitely they do night outs. If you are not doing night out, then no need to attend. You can attend later, Raj. Don't worry about it. You just continue your normal sleep. You can watch the recorded in case it is important for you. Yeah, I want to take another time, but I did not get the other schedule, so I have to take that. Yeah. I will do 6 PM to 12 PM some other time in case I forget a time. Fine. Today's session is about undecidability, problems and languages. Problems and languages. Yeah, Mahendra. Fine. I know it is very difficult to attend for many people who are having different schedule. Yes, you continue your schedule and also attend normal classes. Yeah. Okay, let's look at what I'm going to discuss in this session. In undecidability concepts, it is important to know the words first. Before starting this session, what is decidable? What is RE but not recursive? This is a single word in identifying languages. Not RE and RE. RE another name is semi-decidable. Decidable another name is recursive. Yeah, two names have a lot of confusion, like recursively enumerable and semi-decidable. They are not different words. They are synonym words. Right? If I am using semi-decidable indirectly, that I am using recursively enumerable. Yes or no? Yeah. But undecidable is a very dangerous word, where undecidable is you are not having clarity which undecidable, because undecidability there are two problems are there. This is also undecidable, this is also undecidable. Not RE undecidable, RE but not recursive is also undecidable. So before starting the session, I will talk about each word separately to understand. वर्ड देख के समझ नहीं आता ना, तो वर्ड की डेफिनेशन समझना. इसलिए whenever you are not able to use the words properly, words की definition just to revise before solving any problem. Yeah, Mahendra. right? So let's begin. We have two words, decidable language, decidable problem, right? Something like, set of members is the language, and is that machine does something, that is a decidable problem. Good morning, OP. So problems we treat separately here, but problems are going to help you to solve the language, remember that. So I have given two names to understand these definitions clearly. Now, how do you understand language? Basically, when you are talking about a language which will have the members like W1, W2, W3, and these members can be a string which has a sequence of symbols, or a string which is a machine. It is a string but which is expression. It can be anything. So this W1 basically it's just like a string we call, but string basically it could be like a sequence of symbols, or it can be a language, another language, let's say AB whole star. It can be grammar. That member can be another set. A member can be a even machine. Now that string, what we are talking so far in the languages, the string is going to change its representation, depends on the problem. Now set of strings you may say always, instead of that set of members is a better word, but set of valid strings basically. Every string is a valid which is present in the language. So this string can be a sequence of symbols or can be a language. It's actually we call so far a string, but now the string name is changed as a language. Expression, you can say that. It is regular expression maybe. Even it can be a grammar. Maybe it is CFG or regular grammar. Maybe it is a finite automata. Maybe it is a PDA. Maybe it is a Turing machine. And what not. You can even I can write my own parameter like I will keep a DFA, another one I will keep a Turing machine. A one string definition is going to change to understand the problems now. Everybody, now set of members, set of inputs, set of strings. Now these strings need not be like A, B, something like that. Everybody, but how do you understand this language? If I have something that is, let's say, Turing machine, then give any input like any W you give. WI can be expression, machine, grammar, whatever. This machine is able to understand the problem because TM accepts L, and if W belongs to L, WI belongs to L, it is accepts, so it has a logic, it halts at final, and W not belongs to L, then it's going to halt because the decidable language halts at non-final. Both of them, whether it is the language, it is there in the language or not there in the language, it is going to halt at any cost. Are you understanding what I am trying to say about decidable language, guys? Now your perception has to change. W doesn't mean A, B, 0, 1, 0, something like that. WI can be a machine or grammar or language, or it could be any, because in the world if anything is able to recognize, that is only does by the Turing machine to understand the problems. Of course you have a finite automata PDA, that is to understand how easy that problem is, but today we don't look at what finite automata, how to design a finite automata and PDA. But if somebody designed, the Turing machine can understand that finite automata and PDA too. Okay, everybody, that input can be even finite automata too. This is the language definition. If I want to accept this L by Turing machine, then what you have to do is give input, either it can be valid string or invalid, we don't know. This might present in the L or not, we don't know. If it is present, then definitely it will halt at final because we designed such a way. Have you understood definition of a decidable language? And we have other definitions. Now let's look at definition. Definition. To prove it, if you want to say L is decidable, you need to do something. Directly designing is very difficult, right? Just prove it. L has TM. There is a TM that accepts L, and L complement also has a TM. That means valid members of L and invalid members of L both will have a logic. When L has the TM, it means the all Wi belongs to L will have a logic. And L complement has a TM, that means for all Wi belongs to L complement as a logic. They have logic. Indirectly, both have a logic. W belongs to L, W not belongs to L, both will have a logic. Yes, narrator. Different languages, different motion, like different regular languages, different motion. This L is called as recursive language. If everyone you have the same Turing motion, then how can you do different job? Yeah, based on the application, we keep changing. Okay, now we have another one, problem. Now you might ask something. E is given something like that. E is given M does something. Let's say accepts W. Now this is kind of a problem, guys. This is a kind of a problem. You want to build Halting Turing motion for this. Now give some, it need not be N, it could be any input. I am just writing input 1, and you can give so many inputs sometimes. Like motion is one input, W is another input. Now we are asking the question, even it could have 3 inputs also, but answer comes out as yes or no. If both have logic, yes also you know how to identify, no also you know how to identify, then we say this problem is decidable. Everybody look at how to answer the question. Somebody is asking, it need not be M, it need not be W, it could be any. I'm just giving an example to understand this one. Maybe I ask, is DFA accepts AB, or is regular expression generates AB. This might be DFA, this might be AB, or this could be any other question. So in general, how do you solve this problem is, you have input or inputs. Input can be a mixture of any of, so far I told string, grammar, language, motion, expression. You can input or inputs, depends on your problem. So you have some problem, or you are asking the question there. Yes means it satisfies, no means it doesn't satisfy. Then both have a logic, then we say it is decidable problem. So many examples are there. As I told, is a particular is given DFA accepts a given string W. You can give any string here. Everybody, so 2 things. One is the language, where you have this set of members or set of inputs or set of strings, and another one we have problems too. We have problems too, guys. Right? For this problem, the inputs can be one or more. Remember. Okay, now another definition we have. RE but not recursive language. First I will explain a language definition, then I will explain the problem. When we are saying it is RE, means we have a Turing motion, but we are saying it is not a decidable language. RE but not recursive language. Now you give, it's a language, right? You must give some input. This input can be anything. And suppose this machine accepts L. I am giving this is L as a name. Now what it should do? Of course TM should exist, no doubt, but if you want to say that Wi belongs to L, definitely it halts at final, we will have a logic, no doubt. Not only this, logic exists. Good morning, Simon. And in case if you want to say not belongs to L, we never know. Previously I said all set non-final, that was the decidable. There is always halting Turing machine, but यहाँ पर नहीं होंगे. Right? We cannot say that, but logic not exist. We can't prove the W is not in L because these problems, they don't have a logic for, no logic for invalid strings. Invalid inputs means invalid members, you can say invalid strings, they don't have a logic. It's not general Turing machine, guys, a specific Turing machine where in general definition not belongs to L, we don't know, we say logic might exist, logic not exist, but this Turing machine is trying to say I never have a logic. This is not the general Turing machine, it's a specific Turing machine where it is accepting RE but not recursive. In general Turing machine accepts RE, it might be not recursive or it might be recursive. Everybody? Yes. Okay, if you want to talk about RE but not recursive problem, yes Simon, we have a practice session today, 12 AM to 6 AM. It's not just night, it is a tomorrow complete early morning, till early morning 6 AM. Yeah. Midnight to morning. Okay. Now assume this is a problem. You are giving inputs. You might ask some question like, is TM accepting so and so? You are giving inputs. Now if it says yes or no, but which one you will have a logic to build? Yes, definitely logic exists, because you can say always that TM satisfies or the given problem satisfies something, and no, we can't prove it. There is no way to say no, it might enter infinite loop. Logic not exist at all. Such problems we say RE but not recursive, guys. Then we say this problem P is RE but not recursive. It's not a language, it's a problem now, because we are not forming a set here. Yeah, all these words takes a lot of time, guys. I spend years to understand these words to put into a sequence, and before I started taking this session, you will never find the undecidability in this sequence. The reason is you need to work hard to understand the difficult problems or difficult concepts. Here I only focus on the words, because words only play the game in TOC undecidability concept. And if you don't believe me, just watch any video on anywhere, right? If you can see undecidability, the sequence that I take on this channel, if you find anywhere, you can compare. Yeah. And I only focus on the words first rather than directly discussing the definitions. Not RE language or not RE problem. Now we are talking about a language. Assume that this is doing for not RE. We are talking about L is not RE, but we know that machine should not exist. Suppose you are giving a Wi. When we say machine not exist, no TM exists. When we say, if you can't prove that Wi belongs to L, has no logic, they don't have a logic, then we say TM not exist. If you have a logic for belongs to L, then definitely you have a TM. So I have no machine to understand the valid strings of a language. Then we say that language is not RE. but don't talk about invalid. Invalid may or may not have a logic, we don't care. Why we say the valid strings of a particular L has or have no logic if and only if L is not real. Everybody, so look at, now look at the one word you want to understand in the exam. फर्स्ट इसका डेफिनेशन बाहर आना चाहिए. अगर डेफिनेशन ही पता नहीं, प्रॉब्लम को कभी नहीं कर सकते हम. राइट, गिवन क्वेश्चन इन द एग्जाम, इफ यू वांट टू इंटरप्रेट प्रॉपर्ली यू नीड टू रिमेंबर दिस डेफिनेशन. थोड़ी देर के बाद ही भूल जाओगे गाइस. मैं पता नहीं 2 साल रिहर्सल किया होगा ये वर्ड्स को, सेंटेंस को याद रखने के लिए. पहले क्यों रहते ना यार, कभी कभी इसको लॉजिक बोलते, कभी कभी उसको लॉजिक बोलते यार. इट हैज़ टू बी गुड प्रैक्टिस. Of course, it takes just minutes or seconds or hours, but once it feeds here, or once you feed here, or once you store here, later on everything looks easy. Not RE problem. Now we are talking about problem. First, समझ लेना problem क्या होता, language क्या होता, तभी कुछ कर सकते हम. Right? Not RE problem means you ask some question. I will give you everything. I will give you TM. I will ask some property. Is this TM does this one? Like, is this TM accept this regular? Right, I am giving you language, I am giving you Turing machine. Is the Turing machine accept this language? तो आपके पास algorithm नहीं होंगे तो क्या build कर सकते हो उसके लिए. तो ऐसे वाले problems, you give some inputs, ask some problem. Mostly I may say yes, I know, but if I don't have a logic for S, no के लिए logic हो सकता कभी कभी, yes के लिए logic नहीं है. Suppose हो गया answer. That problem is not RE. This problem P is not RE. Sir, can you give me any example for that? Yes, we have a lot of example. Suppose I ask, is TM accepts only A and AB? That means I am giving you Turing machine A and A with 3 inputs. Here I might give inputs TM, A, AB. Now I have to check, is that TM only accepting these 2 strings, not any other? Then such questions are not possible in the world. How do I know that this TM accepts only A, only AB? For that, remaining all strings should be rejected. Do you have any logic to check? Infinite strings are rejected, only these 2 strings are accepted. Turing machine will never talk about invalid strings because they don't have mostly predefined build logics. Halting Turing machine, we build a logic for invalid strings, but Turing machine, when we speak, it may be halting machine, it may not be halting, we don't know. So in general algorithms, we don't build for invalid strings of Turing machine. Yes, that is how you need to understand the problems, guys. This is a problem now, right? I'm not talking about a language, it's a problem. Okay, now let me talk about decidable, semi-decidable, undecidable. Languages are there, problems are there. How do you categorize them? You speak anything, language or problem, classification is same. You will have a same classification, guys. You will have a same classification. Let me tell you something first. This class is a decidable class. Everybody agree? Assume. Of course, this is not, we are assuming it. It is a decidable class, means all decidables I am saying. You can assume languages or problems, is your choice. It's not just undecidable. ये देखो, it's not just undecidable. Undecidable के word use ही नहीं किया अब तक. Guys, did I use anywhere undecidable so far? Only I have used decidable. Did I use undecidable so far? I have only explained the first three, and it's impossible to understand whether it is undecidable or not without knowing the definition of undecidable. Yes, OP, Can you tell me what is undecidable first? What do you mean by undecidable? Undecidable means, anybody guess, guys? What is undecidable? Means I don't have halting Turing motion. I may have a Turing motion, I may not, but I don't have halting Turing motion, not a decidable. Right? You may have a TM, remember that, or you may not. Still it is undecidable. Yeah, narrator, that is undecidable only, but in undecidable there are two concepts. Which one you are talking about? For that you need my class. Undecidable बोलना बहुत easy है, but undecidable definition easy नहीं है. Now look at, these are all, what are they, guys? All semi-decidable. We can call all RELs, all REs. Problems are language, is your choice now. Its another name is all SDs, set of all SDs, including D. Every decidable, remember that, every decidable is a semi-decidable. Either problem or language, you can take anything. Do not forget this point. And above one is all languages we are talking about. Decidables, REs, everybody's languages. Now, this class, what is this class? What is this one, guys? This is a different class. Here, this comes under set of all REs only, but they are not recursive because they are outside decidable. And from here to here, these are, anybody guys? They are all undecidables. अब तक बता रहे ना undecidable? ये undecidables है. And यहाँ से यहाँ तक they are all not REs because outside RE class. देखो कितना कितना boxes है यहाँ पर. You have to look at them clearly, guys. So many classes are there here. Decidables class is different. Set of all recursively enumerable languages is different. And set of all not REs, undecidables, RE but not recursive, all languages are going to define a different meaning here. Everyone, इसके लिए क्या बोलते हैं हम? इस बॉक्स के लिए क्या बोलते हैं हम? Every language inside this box we have HTM. HTM exist बोलते हैं. TM तो होंगे उसके लिए भी. HTM डिजाइन करना जरूरत नहीं उसके लिए. यही तो दिक्कत है. Undecidable doesn't mean, इन लोग को बोलना पड़ेगा. Undecidable doesn't mean that क्या है? Not lead to yes or no. No. Undecidable means not decidable, means not recursive, means I don't have HTM. It means we don't have HTM. We don't have halting Turing motion, but we may have Turing motion, we may not. पहले इसको समझना बहुत मुश्किल है. इसका मीनिंग undecidable means we don't have halting Turing motion, but we may have a Turing motion. Undecidable is two types. It might be RE but not recursive. वही तो बोल रहा हूँ मैं अभी. Or it can be not RE. इसके लिए TM होंगे, but HTM नहीं होंगे. इसके लिए no TM. Rohit, are you clear? Undecidable, be careful when you use. We don't have HTM, we may have a TM. Undecidable doesn't mean that we don't have a TM, that's wrong. Suppose in case if you don't have a TM, definitely undecidable, Even you have a TM, it could be undecidable sometimes. Clear this point, everybody? But you need to understand which language you are talking about. And here I have clearly mentioned who are undecidable. Outside a decidable's class, everything is undecidable. Good morning, Iqbal. Please like the session if you have joined late, guys. Okay, the same circle, let me explain you some other way to have a clarity. Yeah. You can also draw another way which can help you to understand the classification. The whole world, all the languages in the world, you can divide into just 3. Now, these are all decidables. You can take languages or problems, this is your choice. I am taking languages, let's say. Where is undecidable? Where is undecidable? From here to here, undecidable. ओके ये लिखना बहुत मुश्किल है, अंदर अंदर मत लिखना, बाद में लिखेंगे इसको. Then who is this box? Second box, ये तो all decidable बोल दिया. Who is this box? These are, just don't say REs, गलत. All REs but not recursive. वो recursive नहीं है. But who is going to have a Turing motion, guys? From here to here, we just say all REs. मतलब decidable भी Turing motion है उसके लिए, और RE but not recursive के लिए भी Turing motion है. But जो RE but not recursive है वो undecidable के अंदर आता. यहाँ से यहाँ तक वैसे undecidable languages, including REs but not recursive. इसके लिए TM exist है but HTM not exist है. For this TM exists for every problem but no HTM. इसके लिए no TM और no HTM भी है. Common property you can say no HTM from here to here. No HTM you can say, and another name is no HTM for these problems. Definitely here HTM exists. वैसे डिजाइन करना जरूरत नहीं, TM भी होगा उसके लिए. बात करना पड़ेगा, HTM की बोलना जरूरत नहीं है, TM भी होता उसके लिए डिसाइडेबल, बट डेफिनेशन के लिए HTM जरूरत पड़ता. ओके, एंड यहां से यहां तक वी हैव नॉट RE. क्लियर? So understand, undecidable doesn't mean that just not RE. Here RE but not recursive, this language is also undecidable. Even though you have a TM, not RE also undecidable. Right? But undecidable no need to be not REL. Remember that. Undecidable need not be not RE. It can be RE also. Undecidable need not be RE, sometimes not RE also. Everybody, so those people who can understand this class diagram, they can just begin this chapter. Are you clear? ये 1 hour, half an hour में नहीं आएगा. You have to revise this chapter once in a while to understand this terminology, and to remember this terminology you may require little bit of rehearsal and practice. Yes, if this is a true, you could have learned already when you have studied somewhere else. Are you clear? I'm just talking about the fact because this kind nobody can make it easy until unless you sit and work and understand. It's just like a program, guys. Program somebody explains, will you understand quickly? No. If you sit for half an hour, 1 hour continuously to understand the logic of that problem, then whole program you might remember how many variables, where do you use the loop, and how do we call the recursion. तो पूरा समझने के बाद लगता है यार ओके सीक्वेंस बन गया, यहाँ भी ऐसे होता, राइट। पूरा वर्ड्स को समझने के बाद यू कैन मेक इट ए सीक्वेंस, नॉट आर ई। नाउ चलते स्टार्ट कर लेते नाउ अभी प्रॉब्लम्स, decision properties. We talk about the problems, and I always focus on few things, guys. Remember these three words: decidable, RE but not recursive, and not RE. बस ये तीनों याद रखना. Other words are very dangerous, which are semi-decidable, क्लैरिटी नहीं है क्यों, ये RE की सिनोनिम है. Undecidable, क्लैरिटी नहीं है क्यों, अनडिसाइडेबल के अंदर दो होता, RE but not recursive, not RE. So use only these three because this is also undecidable, this is also undecidable. Semi-decidable, decidable also semi-decidable, even RE but not recursive is also semi-decidable. तो जो लोग यूज करते हैं ना semi-decidable, undecidable, कभी समझ नहीं आता उनको एक्चुअल प्रॉब्लम क्या है. तो you must use only the first three words so that next two words you can employ it. अगर आपको पता चला decidable तो क्या करोगे, semi-decidable बोलो, चलेगा चलेगा, because every decidable is semi-decidable. अगर आपको पता चला RE but not recursive, undecidable बोलो, not RE, undecidable बोलो. बट कोई बोल रहा है undecidable, आपको क्लैरिटी नहीं बनेगा, क्लैरिटी नहीं बनेगा, ट्यूरिंग मोशन है नहीं. undecidable मतलब ट्यूरिंग मोशन भी हो सकता, ट्यूरिंग मोशन भी नहीं हो सकता, बट HTM नहीं होगा. Semi-decidable means TM always exists, but HTM may or may not. We don't know. Everybody? So this is what the people need to use, and if you forgot to use these words carefully, then maybe impossible to imply them properly. Because as a faculty, I spend a lot of time to use these words properly for months, years it took to understand the words in the beginning. Because as a student, I am not also aware, I am also not aware like you, because nobody was there to teach. These words need to be understand properly before starting the chapter. We used to start directly a problem. अरे ये डिसाइडेबल बोल रहा है, क्यों डिसाइडेबल है, पहले डिसाइडेबल की प्रॉब्लम ही डेफिनेशन ही मालूम नहीं होता, क्यों डिसाइडेबल है. तो ये सोचने की यार कितना अंतर पड़ता पता है. ये अनडिसाइडेबल बोलते हैं, पहले अनडिसाइडेबल की डेफिनेशन ही मालूम नहीं होता. एवरीबॉडी आप ही बताओ, अगर आप पहली बार ये क्लास को सुन रहा है तो आपको क्लियरली पता है क्या व्हाट इज अनडिसाइडेबल. ये पढ़ने के बाद भी लगता है यार भूल गया, फिर जाके फिर रिवाइज करना पड़ता. व्हाट इज अनडिसाइडेबल, व्हाट इज अनडिसाइडेबल, व्हाट इज सेमी-डिसाइडेबल पढ़ना मत. व्हाट इज सेमी-डिसाइडेबल मतलब व्हाट इज RE, व्हाट इज RE मतलब यू हैव ए ट्यूरिंग मोशन. एवरीबॉडी अनडिसाइडेबल मीन्स नॉट डिसाइडेबल, मीन्स not recursive, means I don't have HTM. I may have a Turing motion, I may not. शिवा वही तो कहा था ना, सिनोनिम नहीं है, सिर्फ implication. सेमी डिसाइडेबल गाइस, सेमी डिसाइडेबल नीड नॉट बी RE. यही तो गलत किया मैं पास्ट में, RE बट नॉट रिकर्सिव. क्यों, डिसाइडेबल भी हो सकता, इट कैन बी डिसाइडेबल टू, बिकॉज एवरी डिसाइडेबल ऑलरेडी सेमी डिसाइडेबल. तो दिस टू आर नॉट सिनोनिम्स, है ना. सेमी डिसाइडेबल RE बट नॉट रिकर्सिव, बोथ आर नॉट सिनोनिम्स. या चलो जो भी है एवरीबॉडी, सो यू नीड टू हैव अ क्लैरिटी, you need to have a clarity. Semi-decidable can be decidable. Look at in reverse. Look at in reverse. Semi-decidable can be decidable. Semi-decidable can be RE but not recursive. Look at in reverse direction. है ना. तो समझ लो बात को, आप खुद ही डिफाइन मत करना डेफिनेशंस को. Never use your own imagination definitions. Sometimes we imagine oh undecidable means no TM. गलत है. Clear? Can we start decision properties? Yes, RE but not recursive semi-decidable बोल सकते हैं, but semi-decidable need not be RE but not recursive. वो ये बोलना जरूरत है ना. Okay, so we have so many decision properties like halting, problem guys. It's not a language. Something is given to you, you need to understand. Membership problem, emptiness, finiteness. एंड लोग है ना ये बोलता आल्टिंग इज डिसाइडेबल अनडिसाइडेबल, पहले आल्टिंग प्रॉब्लम डेफिनेशन ही पता नहीं है, डिसाइडेबल अनडिसाइडेबल बोलते रहिए, है ना, बहुत डिफिकल्ट वे पीपल ट्राई टू एक्सप्लेन गाइस. टोटलिटी, दिस आर द प्रॉब्लम नेम्स. बिना डेफिनेशन से कुछ नहीं होगा ना. ऐसे दुनिया में बहुत प्रॉब्लम्स है, हंड्रेड्स ऑफ प्रॉब्लम्स है. दिस आर द स्टैंडर्ड प्रॉब्लम्स जस्ट टू अंडरस्टैंड. एग्जाम में वो नया प्रॉब्लम डिफाइन करेगा, फॉलो करना पड़ेगा उनको. डिसजॉइंट, सेट कंटेनमेंट. पहले प्रॉब्लम क्या होता, प्रॉब्लम प्रॉब्लम बोल रहा है ना. व्हाट इज दिस प्रॉब्लम, क्या जरूरत है इस प्रॉब्लम के लिए. halting problem you can apply for machines, you can apply for languages, you can apply for regular expressions, you can apply for grammars. ये क्लियरली बोलना पड़ेगा एवरीबॉडी. तो halting प्रॉब्लम ही है, बट दिस halting वर्ड वी ओनली यूज फॉर द मशीन, सो यू कैन ओनली अप्लाई फॉर मशीन. पर मेंबरशिप है ना, you can use for machine, you can use for language, you can use for grammars, but concept is for the languages, because membership is there in the set we talk about. Like emptiness, you can apply for machine, you can apply for grammar, you can apply for expression, you can apply for even language. ये समझ में आना चाहिए किसको अप्लाई करने वाला है. हम पता नहीं है किसको अप्लाई करने वाला है, सीधा बोलते डिसेबल अनडिसेबल नहीं होता. halting the word came from the machine, तो machines halt होता नहीं होता, grammars को नहीं बोलते कभी, halt होता नहीं होता. Are you clear this point? We talk about the machines, right? Question is like that, is given machine halts on given input, एक input भी देना पड़ेगा, नहीं देगा तो कुछ अलग प्रॉब्लम है. halts on given input, this is the problem name. yes बोल सकते क्या, अगर machine halts no बोल सकते क्या, it depends on the machine type. So find out PDA, halting Turing machine and linear bound automata, deterministic PDA and Turing machine, and every machine you can apply this problem. Some problems say decidable, some problems say undecidable. For some machines when you apply they are decidable, for some machines it is undecidable. समझ लिया बात को. पहले प्रॉब्लम के बारे में पढ़ लो, या डिसेबल अनडिसेबल बाद में आएगा ना आंसर. प्रॉब्लम की डेफिनेशन ही मालूम नहीं है, किसको अप्लाई कर रहा है, कैसे अप्लाई कर रहा है, क्या इनपुट्स दे रहा है उसके लिए. आर यू क्लियर? ओके, halting प्रॉब्लम, आई विल टॉक अबाउट दैट. नाउ व्हाट इज मेंबरशिप प्रॉब्लम? मेंबरशिप यू कैन आस्क मेनी वेज. मशीन को भी पूछ सकते, बट यू नीड टू चेंज द प्रॉब्लम रिप्रेजेंटेशन. इज W belongs to language accepted by machine M. मशीन को भी पूछ सकते, और यू कैन आस्क डायरेक्टली लैंग्वेज, इज W belongs to L. लैंग्वेज भी दे सकते, और यू कैन आस्क ग्रामर, इज W belongs to language generated by grammar. वैसे एक्सप्रेशन को भी पूछ सकते हैं आपको चाहिए तो. लैंग्वेज जनरेटेड बाय गिवन एक्सप्रेशन, अगर रेगुलर एक्सप्रेशंस की बात करना है तो. It depends on what kind of domain you are looking at. Languages is very important. Now here is language accepted by machine. Machine can be finite automata or DPDA. अलग अलग डोमेन्स के लिए अलग अलग एल्गोरिथम चाहिए होगा. Is language accepted by machine equal to pi? Or you can ask for directly, is L equal to pi? Or you can ask for the grammar too, is language generated by a grammar is pi? Finiteness, same. I can ask for the machine, but I'll change the question. language accepted by machine finite? Which finite? We don't know, just a property. Is L equal to finite? Is language generated by grammar finite? And what is totality? And these definitions will play a lot of roles, because here the machines are your domains, or languages are your domains, or grammars are your domains, and for a particular domain you are applying this problem. Is language accepted by given machine sigma star? Means will it accept every string? Or is L equal sigma star? Or is language generated by grammar sigma star? I am asking, is that given input either machine or language or grammar, is it accepting everything, or is it having everything? Is it generating everything? The question word is going to change. Okay, equivalence. I will give you two things. Two machines I will give. Is M1 equivalent to M2? What is the meaning of equivalent? That means is language accepted by M1 is same as language accepted by M2. Indirectly, is L1 equal to L2? Like grammars also you can apply. Are these two grammars are equivalent? And disjoint. What is disjoint definition? I will give you two machines or two languages. Is L1 intersection L2? Two languages I give, or two machines or two grammars equal to pi. Are they disjoint? What is given? L1 and L2. Either directly, or machines or grammars, or one is machine, other can be grammar. It's all choices. Set containments. Set containment. Is L1 subset of L2? It's not operation. We are checking. I will give you L1, L2. Can you check, is it subset of that one? We are not finding a subset. We are checking the subset. Yes. And those people who understood the definitions of these words, then we can remember something about this problem. And almost I spent 10 hours explanation only for undecidability concepts, guys. If you go for Unacademy special classes, so far more than 10 hours class taken. Even it's counting more than, it's not 10, maybe 20 hours, I don't know, I didn't remember exactly, but more than 10 hours class taken just to explain these concepts. Even I want to explain halting problem, I may take even half an hour time, because you need to understand that. Everybody, yeah, I may spend a halting problem, but remaining, it's not easy for me to explain each and every one here. I can help you to remember if you want. So first I will help you halting problem, remaining I will help you to remember them. How to understand one problem in the world? There is some problem, guys. Membership halting. So let's talk about halting. I want to apply halting problem. ये तो easy होता guys. Halting problem for finite automata. What is the definition? Is or whether given finite automata halts on given W. मतलब दो इनपुट आएगा यहाँ पर. halting problem for finite ये नहीं बोलता इनपुट है, वो तो स्टेटमेंट है, राइट. इसका मीनिंग में there are two machines will be given, FA and string. These two are inputs only. This is input 1, this is input 2. दोनों strings है, but एक string is a machine, other string is sequence of symbols. And what you are talking about? This is a problem. Let's say this is a P is your problem. I am talking about a P. If you are saying yes, it means the finite automata halts on W. No, if you are saying finite automata doesn't halt. But ऐसे कोई केस है क्या दुनिया में doesn't halt on W? Is there any finite automata that never halts? Okay, finite automata only moves one direction when the input is over, because input is always finite. When the input is over, it automatically halts. So this never happens. Never happens in general. For PDA, for finite automata, for halting Turing machines, This never happens. Does not halt case never happens, guys. Yeah, Sweta, good morning. Everyone, so this is a trivial problem for finite automata, DPDA, LBA, PDA, HTM. Till HTM, this is a trivial problem because those are halting motions. Halting motions को ये नहीं पूछना सर, ये नहीं पूछना do you halt, ये तो हमेशा halt ही थे वो हम करेंगे, इसलिए सारे halting motions है. They comes under decidable, they comes under recursive languages because you can build a motion always, right? Motion के लिए, language के लिए नहीं पूछेंगे halt or not. अगर Turing motion डिजाइन किया तो वहाँ दिक्कत होता है. Everybody, so the same concept you can apply for finite automata and DPDA, PDA, HTM including LBA. This is a trivial problem. Why trivial? Because this motions always halts. These motions always halts. There is no case where they never halt. Yes or no? And logic क्या है? Find the halts on W. Guys, ये string valid है invalid है तो पक्का तो halt होंगे ना सारे motions, है ना? Whether the string is valid or invalid, we don't care. W is valid or not, पक्का halt तो होंगे. But one halt set final, other halt set non-final, right? So it's not only for final till HTM this definition holds. That's why we say it is decidable. All of them, this problem is decidable. Halting ही पूछ रहा है ना, accept not accept नहीं पूछ रहा है, right? So, but when you apply for, sorry guys, membership halting, okay. And when you apply for this halting for Turing motion, ये हो सकता different. Halting problem for Turing motion. That means previously what we have, that means we can build HTM, we can build HTM for P. That's why it is a decidable problem. Halting problem for TM. Now what does that means is given TM accepts given W. Sorry, not accepts, there's a membership, that's what is given TM halts on given W. But here TM, is it guaranteed in the world? Is it guaranteed in the world every TM halts? No guarantee, right? So you give TM, you give a W, you are asking the question, this is a problem. If you want to say yes, it means TM halts. अगर halt होगा तो logic तो होंगे ना. Halt ही मतलब another name is logic. अगर no बोलना, TM doesn't halt, can you verify? Is it possible to verify doesn't halt? To understand doesn't halt, you must go to never halt. अगर if you go to never halt, the logic तो नहीं होंगे. तो इसके लिए you can say the logic exists because always halts. ये logic है, ये logic नहीं है. No logic to prove that TM doesn't halt. तो ये होगा undecidable तो होगा, but लेकिन हम बोलते हैं RE but not recursive. TM exist but HTM not exist. To prove this, I can design, yeah. TOC बाद में लेंगे निखिल. Yeah. TOC also going to be taken soon, but which is also going to be a 6 hours marathon minimum. Otherwise 2 sessions I will conduct if it is not possible to cover in 1 session. Okay, this is how we are going to talk about, and this problem is RG but not recursive. But it is undecidable. Now, what can I say, guys? Look at how to say halting problem. For finite automata, but internally motion is there, input is there. Two things are there to decide. Halting problem. Even for DPDA, halting problem. For PDA, halting problem. For HTM, halting problem. For even LBA, halting problem. देखो guys, सारे halting problem तो है. If you don't know which motion you are applying, there is no way to explain to somebody. In every problem, two inputs are there. One is the motion, other is input. And can I say this one is decidable? Not only that, this is also decidable. Right? But this is RE problem. Why RE? Because it is semi-decidable. RE but not recursive. Everybody, it means undecidable. It means it is undecidable. Also semi-decidable. RE but not recursive. Also it is semi-decidable. It is also RE. It is semi-decidable. But these are also semi-decidable. ये बोलना नहीं कभी, because RE and every decidable is also RE. Every recursive decidable, another name is recursive. Everybody look at all the problems are semi-decidable, but first few problems are decidable. 5 problems, 6th problem is undecidable. All are semi-decidable here. Look at that. How we got a conclusion. All are semi-decidable, you can say. But in that semi-decidable, you have a clarity. The first 5 are decidable and 6th one is undecidable. Clear? Now I can't spend much time on each problem, which will take a lot of time. So I'll just speak about them. Okay. Halting problem is over. Just let me talk about membership. Understood the problem? What are the things are given? If you want to solve, motion should be given and string, the W should be given, string. Both inputs should be given. Then we are asking is W belongs to, we are not asking just halt, belongs to. Yes means M accepts W. Halt तो होंगे पक्का, but accepts W. No means M doesn't accept. ये M कौन है? फाइनाइट बेटा हो सकता, PDA हो सकता, TM हो सकता, ए मेंबरशिप प्रॉब्लम की डेफिनेशन है. Clear? Now for finite automata, membership is also guys for finite automata, DPDA, PDA and LBA, HTM. By definition they always halt, right? When they always halt, whether the string is accepted or not accepted, they have to halt. So for this problem is decidable, because by definition this motions always halt. But for Turing motion, yes means it will halt at final, but you can't say no, because when the string is not accepted by motion, it might halt or it may not halt. So for TM, this problem is undecidable, but clearly if I want to say RG but not recursive is the proper word to use. it is undecidable, right? Decidable is semi-decidable, उसका दिक्कत नहीं है, undecidable नहीं बोल सकते, but A भी semi-decidable, but this semi-decidable is different semi-decidable. This is undecidable semi-decidable. Everyone, look at how complicated words. Those people who use semi-decidable, undecidable, they have to be very clear. Okay. Now similarly, I'll just talk about remaining emptiness. This emptiness, I can make a table, emptiness and finiteness. If possible, I will make a table at the end again. We can apply for finite automata or regular languages, regulars, DCFLs, CFLs, CSLs, recursive languages and RE languages. Yeah, so here I use a D. D means decidable, and something which is SDUD, SDUD मतलब ये RG but not recursive guys, ये SD में है और UD में भी है. एक और है NR. NR means not real. So I'm using three words here. And emptiness, decidable for regulars, decidable for DCFLs, here up to here. And for CSLs and recursives, RELs, empty, the language is accepting, machine is accepting empty is purely not REL guys. There is no way to understand at all. If the Turing machine is accepting emptiness, there is no algorithm to prove it. Even S also, there is no logic to say, because every string has to be rejected. Every string has to be rejected, so we don't have a logic to verify. And finiteness is same D here. And for CSLs, finite means language is finite. For that also you need to verify entire world to understand finiteness. These are also NR. NR means there is no TM also. There is no HTM, no doubt, but there is no TM also. Yeah. So these words, in generally outside I have not taken the classes, but I have explained in free classes clearly this one. Basically, I explained hours of content to understand this not REL, all these things, but not that much not required. Just remember, other than the D, everything is UD. But which UD? Is it partially decidable or not? That takes time. Okay. Equivalence totality. And LBA anyhow out of syllabus. So LBA you can delete. CSLs. Equivalence problem. I told you 2 languages must be given to verify, or 2 machines. Or 1 machine, 1 grammar is also fine. But 2 things should be given to prove both are doing the same job. Both are accepting same language, or both are generating same language. Depends on the type of model. If you are applying for regulars, DCFLs, CFLs, I'm deleting CSLs guys. Anyhow, you can apply this recursive languages properties and RDLs. Yeah, I know without proving it very difficult. Remember, but in undergraduate most of the people does the same thing. Regulars, it is decidable, even DCFLs also, both are decidable, but remaining equivalents, these are purely not real, because you need to check both are equivalent. So what you have to do, every string, both motions will halt at final or both motions halt at non-final. Equivalence is the not real for all of them. Totality means, is that PDA accepting every string? Right? Are you understand what I am saying? Is that PDA accepting every string, or is that HTM accepting every string? Is that TM accepting every string? Then is it possible to do that? Right? There's no way, guys. Every string, how can I prove that it is halting at final? Infinite strings है दुनिया में, ये not real हो जाता सीधा. Right? Even partially also, S के लिए भी लॉजिक नहीं है यहाँ पर, S के लिए लॉजिक नहीं है, no के लिए हो सकता है, वो अलग है बात. इसकी कॉम्प्लीमेंट बनेगा no. And disjoint and set containment, it's a complicated, but just I am giving an answer. Those people who want to remember, you can. Otherwise, you can watch my other classes, guys. You know how difficult to explain one problem also, but I am explaining this many problems, impossible in 1 hour, 2 hours. You don't know, first time when I have introduced this concept, only one word I took 1 hour, guys. In 2 hours, I am discussing in 2 hours all these concepts in 2 hours. Okay. One is a disjoint. It's just a revision class, you can think that way. If you have any doubt, you can catch me anytime in free classes. Apply for regular languages are DCFLs, CFLs, recursive languages, RE languages. Okay, now disjoint and set containment, these are decidable, and remaining all are undecidable. A disjoint basically comes under L1 intersection L2 is pi. This intersection L2 for DCFLs, basically DCFL1 intersection DCFL2 is always CSL. So this problem is going to be converted, even though you are asking for DCFLs, but this problem converts to CSL's problem. Emptiness of CSL. Emptiness of CSL is already not real. So ये भी not real होता, 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 guys. Set containment, ये कुछ अलग होता. Set containment is L1 subset L2. इसके लिए आप चेक कर सकते is L1 intersection L2 complement is pi. Is L1 intersection L2 complement is pi. Again ये है ना everybody, is L1 intersection L2 complement. Yeah, again this is going to convert into emptiness. So ये भी ऐसे होता, not real, not real. ये याद रखना मुश्किल होता. अगर आपको अनडिसेबिलिटी बोलना है, in case if you want to say undecidable, बहुत इजी है गाइस, बहुत इजी है. देखो ये टेबल को याद रख लो, बन जाएगा एग्जाम में. सिर्फ आपको डिसाइडेबल अनडिसाइडेबल बोलना है, ये टेबल को याद रख लो, हो जाएगा आंसर. So now you remember here halting के लिए सेम रो एंड मेंबरशिप के लिए मेंबरशिप भी, टू प्रॉब्लम्स के लिए सेम रो, एंड एम्प्टीनेस एंड इवन फाइनाइटनेस टू. Equivalence and totality. set containment and disjoint. क्या आंसर है? ओके, दिस इज फॉर रेगुलर लैंग्वेजेस, दिस इज फॉर DCFLs, CFLs, recursive or CSL, you can use the same column. RELs. So remember very easily, D, 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 up to here D, and emptiness, finiteness, equivalence, totality, and disjoint set containment. Remaining all are what? Undecidable. But what kind of undecidability? Very, very difficult. You can say, I'm saying UD, but that's not enough for the exam point of view. They might ask which UD, then you will be in danger, right? Everyone? Yeah, you can easily remember if you want. This is NR. Sorry, first is not NR, UDSD. That is UDSD. I forgot to tell that. This is halting member, same partially decidable, right? UDSD. But remaining all are NR. NR is also UD, but special UD. You can remember this table, and this is undecidable portion. All are undecidable. This is undecidable. Everyone? You can easily remember this table in case if you need in the exam, if they ask halting problem, if for Turing motion, say undecidable but semi-decidable. Clear? Okay. Now languages, guys. If you know that previous ones, you can frame the languages like, L is equal to DFA such that DFA accepts AB. ये language है, but this was taken from the problem. Whoever knows is given DFA, whether given DFA accepts AB. ये membership problem, guys. ये तो डिसरेबल है ना? Membership problem for regular languages. ये डिसाइडेबल होगा तो सेम एल्गोरिथम लेकर हर इनपुट को अप्लाई कर सकते हैं एल के अंदर भी. इफ यू कैन बिल्ड HTM, वी कैन बिल्ड HTM एग्जिस्ट टू एक्सेप्ट L, बट इनपुट आएगा DFA, सम DFA. जो DFA एक्सेप्ट करेगा वो L के अंदर रहेगा. यस मतलब DFA बिलोंग्स टू L, नो मतलब DFA नॉट बिलोंग्स टू L. जो एक्सेप्ट नहीं करेगा L के अंदर नहीं रहेगा. एवरीबॉडी? तो same algorithm you can use to verify every DFA in the world. So this problem is decidable. This language is recursive. L, now you can say decidable language. अगर decidable हो तो recursive भी होगा because another name. अगर recursive हो OB, that is also recursively enumerable. Another name of recursively enumerable is semi-decidable. Clear? This is how we interpret the languages. Let's try second problem. But what is the language name, guys? Set. It's not a one DFA set of, but problem is different. We just took one problem to solve this. Set of all DFA चाहिए हमको, where every DFA accepts AB. Similarly, I can ask remaining questions too, but famous problems I will explain, guys, instead of discussing everything too. Now I have 3 questions. Actually, I didn't explain that previously, but I will explain here. I have a language where I will collect all the Turing machines, where those Turing machines accepts, let's say, any string. I am taking epsilon, it's fine. लोग को ऐसे समझ में आता है यार, लोग बोलना स्टार्ट किया TM doesn't accept epsilon, TM doesn't accept epsilon. ये गलत वर्ड है. TM accepts बट वेरीफाई नहीं कर सकते हम, ये समझ लो बात. We can design a TM to accept epsilon, but we can't verify whether the given TM accepts epsilon. ये मेरा पढ़ना आना चाहिए. We can design TM that accepts what? Epsilon. ये तो दिक्कत नहीं है, but we cannot verify given TM, वो तो ऑलरेडी डिजाइन वाली है, that accepts epsilon. ये नहीं कर सकते हम. We cannot verify given TM whether it accepts epsilon or not. We cannot verify given TM whether it accepts epsilon or not. We really don't know, So understand, this is we are designing. ये तो already given. Designed one. Yeah, these 2 problems are different, guys. ये नहीं बोलना कभी TM doesn't accept epsilon. नहीं बोलना. TM can accept, but we don't know how to check it. Right. What is the meaning of this? Set of all TMs. बहुत होंगे दुनिया में. Set of all TMs where every TM accepts epsilon. Set of all Turing machines where आपको पहले एक TM की पता है क्या, प्रॉब्लम बना लो. Whether given TM accepts epsilon. इसके लिए क्या लॉजिक बनना चाहिए? ये मेंबरशिप प्रॉब्लम है ना. दिस इज मेंबरशिप प्रॉब्लम. अगर TM इनपुट दिया, जो भी दे दो, यस नो, क्या बोल सकते हैं आप? विच वन यू कैन से? इफ इट इज एक्सेप्टिंग एप्सिलॉन, यस इट हॉल्ट्स एट फाइनल. मतलब लॉजिक होंगे पक्का, मतलब लॉजिक एग्जिस्ट. अगर TM doesn't accept epsilon, लॉजिक नहीं होगा. क्यों? इट माइट go to infinite loop, or it may never halt, because TM alts are not, we don't know. TM alts or doesn't not halts, don't know. in general अगर आप ऑलरेडी बोल दिया HTM तो कर सकते हैं आप. एवरीबडी, अगर सेम प्रॉब्लम, ये तो प्रॉब्लम क्या हुआ, SDUD हुआ. SDUD मतलब it's semi-decidable, and UD it is recursively enumerable. You can say that. Simply you can say UD, and SDUD means RU but not recursive. Semi-decidable and undecidable. But same problem, if I give for the HTM, बोल रहा है ना HTM ही दे रहा हूँ इनपुट, कोई नहीं आएगा सामने. इनपुट इज HTM, देन टॉक अबाउट HTM ओनली. समझ में आना चाहिए. इनपुट्स आर ओनली HTM नाउ. अब प्रॉब्लम बनाना पड़ेगा. मेंबरशिप फॉर HTM, वो तो डिसाइडेबल है ना, मेंबरशिप एल्गोरिथम है ना HTM के लिए. यू कैन यूज दैट. एस नो दोनों के लिए लॉजिक बनेगा. सो दोस HTM विच एक्सेप्ट एप्सिलॉन, पुल दैट एंड पुट इन द लैंग्वेज. So this problem is decidable. Same logic, whether given HTM accept epsilon, yes भी बोल सकते, no भी बोल सकते. S होगा तो alts at final, no होगा तो alts at non-final, because the name is halting Turing machine. ये कभी infinite loop never halt केस में नहीं जाता. Yes, everybody. So इस प्रॉब्लम को recursive भी बोल सकते हैं, and इसको RE भी बोल सकते हैं. but undecidable मत बोलना because already decidable. Clear? Now next one which is really important for you, यार एडिंग डिसाइडेबल लैंग्वेज रख दिया. यस डिसाइडेबल, ये डिसाइडेबल एक हो गया. ये प्रॉब्लम आया सेमी डिसाइडेबल वाली बट अनडिसाइडेबल. RE but not recursive. Now look at another one. L is equal to TM where TM accepts, वो तो गिवन स्ट्रिंग है, ये तो स्ट्रिंग नहीं दिया, सम स्ट्रिंग. क्या होता है ये? What is the difference? What is the difference between these two? Accepts epsilon. ये तो पर्टिकुलर स्ट्रिंग है, दिया हुआ आपको, तो वहीं पर चेक करोगे ना. बट L1 को कैसे कर सकते हैं? L1 you can reduce to L2 but it takes time, right? Then how to understand when the string is not given, the given TM accepts. तो आपको ये प्रॉब्लम सॉल्व करना चाहिए आपको पहले. कितने लोग को पता नॉन एम्प्टीनेस वो एम्प्टीनेस की कॉम्प्लीमेंट है. नॉन एम्प्टीनेस प्रॉब्लम होता वेदर TM accept something, वही तो है. ये नॉन एम्प्टीनेस प्रॉब्लम है. इट विल टॉक अबाउट वन TM वेदर इट एक्सेप्ट सम स्ट्रिंग. इनपुट तो TM है, तो नाउ यू नीड टू वेरीफाई yes and no. कैन यू से बोथ? अगर एक्सेप्ट सम स्ट्रिंग yes बोलना चाहिए, डजंट एक्सेप्ट एनी स्ट्रिंग नो बोलना चाहिए. बट किसके लिए लॉजिक होगा? नो मतलब एम्प्टीनेस, एक्सेप्ट नथिंग. yes मतलब एक्सेप्ट समथिंग. आई एम गोइंग टू प्रूव दैट yes के लिए लॉजिक होगा. नो मतलब एम्प्टीनेस, एम्प्टीनेस तो बिल्कुल लॉजिक नहीं है, नॉट आइडियल बता दिया ना, लॉजिक नॉट एग्जिस्ट. तो हम प्रूव करने वाला है लॉजिक क्यों एग्जिस्ट है व्हेन इट एक्सेप्ट समथिंग. एनीबॉडी? एक ही TM दिया हुआ, इनपुट इज TM, बट यू नीड टू चेक इज द TM एक्सेप्ट सम स्ट्रिंग. तो आपका टेप है ना, वो टेप क्या है? इन्फिनिट टेप है ना आपका. वी हैव इन्फिनिट टेप, राइट? वी हैव इन्फिनिट टेप फॉर द ट्यूरिंग मशीन. आई एम गोइंग टू बिल्ड ए ट्यूरिंग मशीन दैट इज गोइंग टू कॉपी द TM, गिवन TM. जो TM दिया ना उसको कॉपी करते रहेगा. बट लेकिन एवरी टाइम इट आस्क will you accept epsilon W1? Next it will copy here. Will you accept W2, W3, and over sigma, the sigma star is countable, so I can enumerate one by one after other. Same TM को thread जैसे copy करूँगा, but I keep on asking one by one. I don't ask just one. If I ask just one, it might enter infinite loop. Then you will never go to next thread. So I create threads one after other, but I keep on asking epsilon A, B, double A, B, and so on. If any TM halts at final over answer, yes के लिए मैं बोल रहा हूँ, no के लिए तो आंसर नहीं है मेरे पास. If any TM halts at final, then we got a logic for S. No के लिए लॉजिक नहीं है, ये भी याद रख लेना. In case no TM halts at final, लॉजिक नहीं होता. If every TM, what we are talking about, goes to infinite loop, suppose, right? Even some TMs halts at non-final, but other TM go to infinite loop. You don't understand what is going to happen, doesn't accept. So I don't care. Okay, what is this problem now? It is RE but not recursive. SD and UD. And it is, you can say RE, you can say UD, all you can say. Now similarly you can write so many problems, but I am going to talk about one more here. L is equal to TM, previous year gate model question, TM such that TM accepts 2021 length string, some 2021 length string. So now the same problem, TM accepts some string. When you don't know the string, you are able to identify if in case accepts up to 2021 ही start करना है ना. Collect all 2021 length strings in the world over given sigma, few होंगे. So every string create one TM, every string create one TM. If any TM or set final, put in this language. तो S के लिए logic होंगे. If you want to verify this, yes के लिए logic होंगे. Definitely by creating the thread concept. Why? Because we have finite strings, finite number of strings with a 2021 length. 2021 length depends on your sigma, and each string create one thread. Each string create one thread for the Turing machine. मतलब TM के लिए W1 same TM, but create another thread, ask W2, and how long? We know only few. Let's say WK. K strings are there, assume. If any TM or set final, just put it in this TM. But no के लिए logic नहीं है, क्यों? Every TM may go to infinite loop, or even one TM goes to infinite loop, you will never come out with an answer. This is again same SD and UD, RE but not recursive. Yeah. Not RE है ना, बहुत खतरनाक है. L is equal to, आपको पता है ना, TM accept some string. TM accept some string. मैं ये बोलूँगा अभी, TM accepts only string AB. इसका मीनिंग क्या? ओनली एप्सिलॉन बोलो चलेगा. इसका मीनिंग ये है, TM such that language accepted by TM as only one string. कोई और string accept नहीं करेगा. It means whether you can convert into a problem whether given TM accepts only AB. ये प्रॉब्लम का नाम है गाइस, है ना. इसके लिए इनपुट TM होंगे. यस नो के लिए लॉजिक है क्या, चेक करना पड़ेगा टू अंडरस्टैंड दिस प्रॉब्लम. नाउ टेल मी गाइस, ये बहुत इंटरेस्टिंग प्रॉब्लम है. इफ यू वांट टू से यस, इफ यू वांट टू से यस, व्हाट इज द मीनिंग ऑफ यस हियर? S means the TM accepts only AB, means you have to prove that for AB you will alter final state, for remaining all the strings how do you say they are rejected? No logic to verify it. प्रतीक S के लिए लॉजिक नहीं होगा. ये सिर्फ TM accepts AB नहीं है, TM accepts only AB. क्या प्रूव करना? AB accepted, बस इतना नहीं होगा. रिमेनिंग ऑल शुड बी नॉट एक्सेप्टेड, उसके लिए लॉजिक नहीं है. एंड रिमेनिंग ऑल स्ट्रिंग्स शुड नॉट बी एक्सेप्टेड. आधा करके नहीं छोड़ सकते प्रॉब्लम को कभी. कैसे कर सकते हैं हम? ट्यूरिंग मशीन को एक स्ट्रिंग भी पूछो, आर यू नॉट एक्सेप्टिंग, वो अनडिसाइडेबल है, लॉजिक नहीं है. एवरीवन, यस के लिए लॉजिक नहीं होता. क्यों? एक्सेप्टिंग ए बी यू कैन वेरीफाई, बट एक्सेप्ट्स ओनली ए बी इज डेंजर. एक्सेप्ट्स ओनली मीन्स ओनली ए बी एक्सेप्टेड, नो बडी एल्स एक्सेप्टेड. बट टीएम को इतना पता क्या एक्सेप्ट करेंगे, है ना. फाइनेटनेस, एग्जैक्टली, दिस कम्स अंडर, यू कैन रिड्यूस दिस प्रॉब्लम टू फाइनेटनेस. This is the finiteness concept, exactly. Somebody can convert, okay, language is the finite. एक स्ट्रिंग हो, दो स्ट्रिंग हो तो फाइनाइट के अंदर आता. दिस इज अ प्योरली नॉट REL. आपको ऑलरेडी पता है फाइनाइटनेस, यू कैन आंसर डायरेक्टली नॉट RE. क्लियर? सो नॉट RE डायरेक्टली. एंड यहाँ पर इतना करना गाइस, व्हेन वी आर टॉकिंग अबाउट 3 प्रॉब्लम्स, वेदर TM accepts string W, like string AB, this W is given. One problem, this is a problem 1. Problem 2, whether TM accepts some string, string is not given, but some string. P3, whether TM accepts only the string W, some W is given. And you know ये problem क्या है? This first problem is what? Membership. क्यों string दिया हुआ ना, membership. ये problem क्या है? Some string है ना, तो non emptiness, emptiness की complement है. Accepts only string ना, ये finiteness के अंदर आता. बट एनी हाउ यू नीड टू आंसर प्रॉपरली. जो पहली वाली है ना वो RE बट नॉट रिकर्सिव है प्रॉब्लम. जो सेकंड वाली वो भी RE बट नॉट रिकर्सिव है, बिकॉज एक्सेप्टिंग समथिंग यू कैन क्रिएट ए थ्रेड, यू कैन वेरीफाई. एंड ये वाली है ना सीधा नॉट RE वाली है. बट ये याद रखना, ऑल द प्रॉब्लम्स आर अनडिसाइडेबल, ऑल आर अनडिसाइडेबल. All these problems are undecidable, all are undecidable. ये कभी नहीं बोलना, because undecidable के अंदर 2 चीज होता, कभी कभी नॉट RE होता, कभी कभी RE भी होता. क्लियर? यस. देखो एक प्रॉब्लम के लिए आप यू नीड टू पुट एन एफर्ट टू अंडरस्टैंड द डेफिनेशन ओनली, तो उससे आंसर बन जाता आपको. TM को हमेशा आप ये पूछ लो आर यू एक्सेप्टिंग, तभी कुछ आंसर आएगा. आर यू नॉट एक्सेप्टिंग तो लॉजिक नहीं होगा. इन केस TM एक्सेप्ट समथिंग, यू आर ऑल्सो आस्किंग द सेम थिंग, इट विल गिव यू आंसर. ओके, anyhow that takes much time. And guys, today I hope I have given the definitions of clear cut of decidable, clear definition of decidable, and RE but not recursive. इसको ही बोलते हैं RE बट नॉट रिकर्सिव, को ही बोलते हैं SD एंड UD. दोनों एक नहीं, इसमें दोनों चाहिए हमको. एंड नॉट RE. ये 3 प्रॉब्लम्स ज़्यादा क्लैरिटी होना चाहिए, तभी आपको बाद में क्लैरिटी बनेगा. व्हाट इज सेमी डिसाइडेबल, ये बाद में बनेगा. सेमी डिसाइडेबल अनदर नेम इज RE, एंड अनडिसाइडेबल अनदर नेम इज नॉट डिसाइडेबल. And I want you to understand the definition of each word before answering any question. And you have hundreds of questions. I have taken so many classes, and on this channel marathon also I was taken on undecidability problems. You can watch those videos, and tomorrow we will practice a lot of questions on this, identifying regulars, DCFS, decidables, and all of them we are going to mix, and tomorrow we are going to solve them. In case if you want decidability, this practice, tomorrow entire class we can devote to identifying these languages. Yes, most important but very very easy. Those people who can understand these 5 words, the whole game is in these 5 words, guys. Okay, fine. And thank you so much for joining my session. And after this class you have operating system, please attend that at 11:30 AM. Then you will have data structure at 2:30 PM today. And in case if you need a plus or iconic subscription, you can use my referral code DEVALIVE. And soon from Jan 18th we have one batch which is going RBR sir is going to start a batch, and you can start enrolling now. use DEVALIVE referral code, and so many batches are going to start soon, and we will inform you. And use DEVALIVE referral code to get the subscription, and you can watch any course, any educator class you can attend, and all are free inside. And in case you need any help from me, you can contact me anytime to help. And in case if you want to know the subscription prices, you can look at. Yes, thank you so much. And this is a 2 months 2 years price 39,600 for plus, and iconic you have 66,600. Use referral code to see the total price. And this is my URL unacademy.com/devagate to access all my free classes, and subscribe to our Telegram channel Unacademy Gate CS. Yeah, we have so many YouTube channels, and all of them are free, and many more YouTube channels are going to come. And please attend these YouTube channels if they are relevant to you, or share with your friends if they want prepare with us. And thank you so much. Yes, it's your choice, Nikhil. Yeah, I will share. Okay, and please like the session, and also share with your friends and subscribe. Thank you so much. Bye bye. Take care.